Good day, everyone. For today's discussion, we are going to tackle the crustal deformation and mountain buildings, prepared by Mr. Kian P. Escartin and Miss Clarice Sheena M. Lagas. So first, I'm going to discuss the crustal deformation, and before we start, these are the objectives of the topic. First, describe the structural geology, under that, the crustal deformation. Second, discuss the types of deformation. Third, discuss the parts and types of fold. Fourth, discuss the types of folds. And lastly, joints. In the structural geology, crust is the thinnest layer of the earth, and deformation is the change in size or shape. Under that are stress and strain, which are directly proportional to each other up to an elastic limit, where stress is a force applied to a given area, and strain is a change in shape or size caused by stress. The relationship between stress and strain is not always straightforward. And why do rocks deform? In stress, the cause of deformation under these are compression, tension, and shear. In compression, squeezes a rock mass or convergent. In tension, pulls apart rock bodies or divergent. And shear causes one part of a rock body to move past another or transform. In the figure, it shows the rock's deformation. These are the types of deformation: elastic, plastic, brittle, and ductile. In elastic, it bounces back to original size or shape. In plastic, it's a permanent change. In brittle, involves the fracturing of rock when a rock strength is exceeded such that it cannot respond elastically, occurs near the surface. Ductile, that produces a change in the size and shape of a rock body without fracturing, occurs at depth. These are the factors that influence and affect the formation: the temperature, confining pressure, rock type, and time. In temperature, at high temperature, deep in Earth's crust or adjacent to a heat source, rocks are nearer their melting points and are therefore weaker and more capable of ductile deformation. Confining pressure. It increases with depth and squeezes rocks equally from all directions, so it tends to make them harder to break and less brittle. Rock type. The manner in which a particular rock type responds to stress is greatly influenced by its mineral composition and mixture. And time. If stress is applied to a rock unit too quickly, the rock will deform elastically until its strength is exceeded and it will fracture. Fold is a result from ductile deformation of rock. There are two parts of a fold: limbs and axial plane. Limbs are the two sides of a fold, and axial plane is an imaginary surface dividing a fold along its hinge line. The figure shows the fold and its parts. There are types of fold. Anticlines are the upfolded rocks. Synclines is downfolded rocks. And monocline often result from buried faults. We have also a circular folds. We have two, the dome and basin. Dome is a curved formation or structure, an upward displacement, and basin is a depression or dip in the Earth's surface, a downward displacement. We have this kind of faults: deep slip fault, which is movement is mainly vertical; normal fault, hanging wall block moves down relative to the footwall block; reverse fault, hanging wall block moves up relative to the footwall block; thrust fault, fault's angle is less than 40 degrees; and lastly, strike slip fault. The slip movement is mainly horizontal. In this figure, it shows how faults looks like in normal deep slip or normal fault, reverse deep slip or reverse fault, and thrust fault. These figures show the strike slip fault. If you are right-handed, it is called dextral, and if you are left-handed, it is called sinestral. Joints. Joints is a fracture with no movement, and it most occur in a parallel groups. Joint is a break or fracture of natural origin in a layer or a body of rock that lacks visible or measurable movement parallel to the surface of the fracture. The next topic will be discussed by Ms. Lagas.
Good day, everyone! So, for today's lesson, I am going to discuss mountain building. And before we start, these are the objectives of today's topic. The first one is to describe the structural geology, and under that is the mountain building. Second one is to discuss the types of mountain building. Third one is to discuss the collisional mountain belts and their feature. So the geologists came with a word for mountain building called orogenesis. And so the reason why they came up with this term, it's because a lot of things can happen in the process of creating mountains. So we kind of give it a blanket term called orogenesis. Or oros means mountain and genesis means come into being. All the processes that collectively produce a mountain belt is called orogenesis. Most mountain building occurs at convergent plate boundaries and create compressional mountains. The model showing you how the mountains move. This is an example of an compressional mountains. Types of mountain building. First one is the island arc type. Second one is the Andean type. And third one is the Cordilleran type. So the first type of mountain building is associated with subduction. Subduction zone is a convergent plate boundary, and you have here a steady subduction of ocean lithosphere. This one. The water creates and melts in the asthenosphere mantle, and those rise up, thicken the overriding crust, and some erupt to form volcanic island arcs. And if this occurs over millions of years, this leads to Andean type. You have ocean and continental crust converging. The subduction ocean lithosphere being taken down, melts are generated, these thickens and erupt at the surface, and a lot of them crystallize deep underground as intrusive igneous rocks. Example for this is the Andes Mountains. The process is we start off with a passive margin and there's no subduction there. But then there's an onset of subducting ocean lithosphere, the trench, accretionary wedge starting to form and creating continental volcanic arc. Those thrust faults start to form and a mountain chain as you can see here. The Cordilleran. This is more complex mountain building and it's related to things like ocean basins that are sort of closing essentially, and island arcs are microcontinents colliding with larger continental crust. Small crustal fragments that were formerly microcontinents, island arcs, or ocean plateaus are created as a result of this process and are known as terranes. India, which was sort of its own continent, collided with Eurasia while carrying the leading edge of a subducting plate that was eventually ran out. Initially, there was a continental volcanic arc in Eurasia. When a subducting plate tapered off, it generates a continental crust, which is what is pushing up all the crustal rocks and generating the Himalayan mountains. An environment known as a convergent plate boundary was now pushing the two plates against one another. Convergent plate boundaries come into two different varieties. One is an ocean-continent convergent plate boundary, in which the water-heavy oceanic slab is subducted underneath the lighter continental slab. The other is a continent-to-continent convergent plate boundary, where both slopes buckle at the plate boundary and the crust is pushed upwards rather than one getting buried beneath the other, as it does in the Himalayas. This illustrates how the Himalayas were formed as a result of the collision of the Eurasian and Indian plates. Rocks near the margin of the Eurasian and Indian plates and sedimentary deposits that were present between convergent continental plates were elevated by compressional forces during this orogeny. Numerous overthrust faults were also produced by these forces. The Appalachians are some of the oldest mountains in the world. They are much older than the Rocky Mountains, even though they are shorter due to millions of years of erosion. This event also displaced and further deformed the continental shelf sediments along thrust faults. So for more information, you can access here in our references for crustal deformation. And for informations about mountain buildings, you can access here also. And that's all. Thank you for watching. God bless us all.